2017. I'm Christina from we.CONECT, and I'm really happy to be with Alex Kirlik from the University of Illinois. Alex, welcome to the conference, and thank you so much for your time to participate in the interview.
Well, I'm glad to be able to do so.
Thank you. As a start, do you mind just briefly introducing yourself and tell us a bit more about your background?
I'm currently a professor of computer science at the University of Illinois, Urbana-Champaign. As an interdisciplinary researcher, I have a foot in a number of different disciplines that are relevant to the design of human technology systems, which is one of the major themes of this meeting. So I have joint appointments at systems engineering, at psychology, at electrical and computer engineering, and with one of our major labs on campus where we do our human-in-the-loop simulations and experiments, which is called the Beckman Institute, which is our primary and premier interdisciplinary research lab on campus.
You've also presented a case study today on using intelligent vehicle automation to drive interfaces as well as cars. Tell us a bit more about that. What insights are you sharing?
I've been looking at the interaction of humans and automation for almost my whole career now. It was part of my PhD dissertation way back in the day. And almost all of that research, which has been funded by both NASA and the National Science Foundation, has been in the aviation domain. And we know there have been significant problems associated with introducing higher and more sophisticated levels of automation in the modern airliners. The automation is often so powerful and, in the terms of some of my colleagues, strong and silent, that the flight crews lose situation awareness on what's going on with the automation. They may be talking about, other things and may not be really paying close attention to what the airplane is doing. And there's also a design issue here in that we haven't yet done a sufficient job at designing interfaces to reveal to the flight crews what the automation is doing. So we've pretty much got the problem pegged of how you create a nice set of interface displays to help the pilot understand what the airplane is doing and the relationship of the airplane to the airspace and the ground. But we haven't yet done a sufficient job of supplementing those aspects of the interface with additional sources of information that keep the pilots informed and engaged about what the automation is doing. So when the automation finds itself unable to handle the current situation and has to call the flight crew back into the loop, we often find serious problems and even significant loss of life due to the difficulty that the pilots face. And I started to see similar types of problems come up in driving now that more advanced in autonomous types of technology is being put into cars. So due to the fact that one of our more recent projects was funded by NSF, and NSF is funding basic science, mainly in engineering, I was giving a presentation at one of the annual principal investigators meetings at NSF just outside DC. And I had numerous people in the audience who I did not know come up to me and ask me about the relevance of the research that we had presented in aviation on how to effectively couple humans and automation in a much more integrated way. Asked me about the implications of that for driving, because they were there interested in driving and maybe had done some research in driving. In addition, the two other factors got me into kind of the driving world, if you will. A couple of years ago, I obtained a visiting scholar position at a research lab in the Boston area. And one of the types of research that lab is very well known for is driving safety. And they have both simulators, a test track, and in fact, a couple of the people who are researchers there are people I'd known from back in the day or went to school together or was a student. So that got me sucked into the driving world a little bit. And then finally, a number of my colleagues who used to be almost solely aviation people, like my friend and colleague Steve Kasner, who's out at NASA Ames, who's talked at this venue before in previous years, either at the Berlin meeting or the Detroit meeting. And we interact, very often over email and so on and so forth. And he's taken a turn into the driving world, and so and has we've talked numerously about how there are both positive and negative kind of analogies or lessons learned or not to be learned to take what we've learned in aviation and apply it to driving.
How realistic is it? Because you're talking about automation in the aviation industry, and how hard it could potentially be to keep the crew in a loop in case something really happens, to alert them. And all the learnings that you might have had already or might potentially acquire in the future, how easily is it to transfer them really to the autonomous driving industry when it comes to cars?
That's a great question, and I had it this morning right at the end of my talk. So at a very abstract level, I think that the concepts that we presented this morning do have some merit. They should, in my view, at least be explored. There is currently a technical issue in introducing very high levels of automation into cars today. It's widely known and appreciated by the attendees at this meeting. And this issue is the human needing to jump back into the loop because the automation can't handle various things. And because of the complexity, uncertainty, heterogeneous nature of the driving environment compared to being 30,000 feet in the air, it's going to be a long time before we expect to achieve the level of safe and effective automation in driving that we currently have now in aviation. So this issue of the handoff is currently holding up the works, if you will, for some people who would like to go down that route. Not everyone does. What we've done is try to realize that that is a derivative problem, in that it's a hard problem to solve, but maybe it derives from how we've ill-conceived the problem in the first place about how to put humans and automation together. And so what we presented this morning was a way of kind of flipping. I described it in terms of a figure ground shift. We described our research on a transition from the dominant paradigm here, which is that the human will supervise the behavior of the automation and jump in the loop while necessary, to a design paradigm where the automation looks over the shoulder of the human and jumps into the loop when necessary. And so we think that is a potential point, that design framework that could be approached, that we haven't seen approached in driving. But there are, in fact, dissimilarities between the aviation case and the driving case, especially in terms of timing, that need to be deeply considered before you would just blindly and unthinkingly transfer the aviation research into the driving domain.
Apart from the case study you presented, what else has brought you to this conference? What expectations did you really have?
I need to learn more about the driving environment and the research community and the technology community and the business community if I would like to have my research inform, especially driving safety. I'm not a business person, if you will. I'm an educator, researcher, teacher, so forth. And I'm in it for for trying to make the world a better place and safer place. And if we have concepts that we've developed through my career, in this area that could serve this community, it's taxpayer funded. So for at least all of the U.S. taxpayers in the audience, they own the ideas that I presented today. So it's, in a sense, trying to give back to this industry research that has been done, paid for by the American people.
Thank you so much for sharing your insights, Alex. It's been really interesting, really good to meet you, and I hope you enjoy the rest of the conference.
Thank you. I've enjoyed it very much.